Dear students, welcome to my YouTube channel, आओ Chemistry सीखें. Let's enjoy chemistry. Today, I have brought you the second lecture on three-component system. And in this lecture, we are going to study three-component liquid systems. And within that also, we are going to focus on one pair of partially miscible liquids. So, आओ Chemistry सीखें. Let's enjoy chemistry. Before moving further, let's have an idea about different types of three-component systems. Three components of the three-component systems may be solids or solids and liquid, or all three may be liquids, or in some cases they may even be gases. So, first type of three-component system is a system that involves solid phases. An example of this type of system is a system consisting of lithium nitrate, sodium nitrate, and potassium nitrate. It is a simple three-component system where components are mutually completely miscible in the liquid phase, and these are the solids that separate out during cooling do not form solid solutions, but each pair of solids form a eutectic mixture. This type of three-component systems are useful in studying alloys, ceramics, and glasses. But our main focus on second type of three-component system, that is where all three components are liquids. Now, when all three components are liquids, they may further be divided into number one, all three components which are completely miscible liquids, or all three components which are completely immiscible liquids. And third case, all three components are partially miscible liquids. And this third case can further be divided into number one pair is partially miscible and the second one is miscible in both the components. Second one is formation of two pairs of partially miscible liquids. And third one is formation of three pairs of partially miscible liquids. So all three components are liquid can be divided into three cases, and the third one where three components are partially miscible liquids can further be divided into three more types. And today we are going to study the first one, all three component systems which form one pair of partially miscible liquid, and the third component is miscible in both the components. So let's start our main topic, that is the three component system of liquid-liquid solutions, which result into formation of a three component system where one pair of the liquids is partially miscible and the third one is miscible in both the components. What is the exact meaning of this topic? Let us understand with the help of one example. Let us say our aim is to make a three-component system where all three components are liquids. And we take three liquids A, B, and C. And we take these three liquids in such a way that A and B, or B and C, or A and C are partially miscible, whereas the third one is separately miscible in both the components. In our present case, we have taken three liquids A, B, and C in such a way that B and C are partially miscible, whereas A is a liquid that can be dissolved in A as well as it is miscible with C. So these three liquids, namely A, B, and C, form a three-component system where one pair is partially miscible and the third one is miscible in both separately. Example of such a system is a mixture of chloroform, water, and acetic acid. Out of these three, chloroform and water form a pair of partially miscible liquids, whereas acetic acid is miscible with chloroform as well as water separately. We are going to study this three component system with the help of triangular plot, which we had discussed in our last lecture. It is an equilateral triangle. One vertex of this triangle represents the first component A. Second vertex represents 100% composition of second component B, and similarly third vertex represents 100% composition of third component C. And we start with B and C. Suppose a mixture of B and C is taken at a constant temperature. From our example, we can say we had started with a mixture of chloroform and water taken at a constant temperature. As we know, B and C are partially miscible. Let us say when we take large quantity of B and very small quantity of C. In such a case, C gets mixed with B because these are partially miscible. Partially miscible means a part of C will be dissolved in B. Similarly, a part of B will get mixed with C. In this case, we have taken large quantity of B and very small quantity of C. Let us say 95% of B and 5% of C. And let us say at this composition, or where percentage of C is 5 or less than 5, it completely mixes with B. So at this composition, or a composition where C is below this percent, it will form a conjugate solution. Similarly, let us take large quantity of C and very small quantity of B in such a way that B gets completely mixed with C. For example, if we take 90% of C and 10% of B, or less than 10% of B, if they get mixed in these ratios, B gets dissolved in C completely. So if we maintain these ratios, we get two conjugate solutions of capital B and capital C. Conjugate solution means capital B and capital C are partially miscible liquids. But when one is taken in very small amount and other is taken in large quantity, the smaller one gets dissolved in the larger one complete. So there may be formation of two conjugate solutions of B and C at two different compositions. For example, in case of large quantity of B, it is 5% of C and 95% of B, whereas if we take large quantity of C, the conjugate solution is 10% of B and 90% of C. Or in general, we can say a conjugate solution forms at composition B and C, which is represented in the graph as small b and C. That means when B is 95 and C is 5, we get a conjugate solution. Or when C is 90 and B is 10, we again get a conjugate solution. So small b and small c are the composition of conjugate solutions. Now what happens if we dissolve A in these conjugate solutions? Since A is miscible with B as well as C, so when A is dissolved or mixed, A distributes itself to both the layers and the layers become conjugate ternary solutions because in those layers B and C were already present as conjugate solutions. Now A also got distributed in both the layers, so it becomes conjugate ternary solutions. A conjugate solution which has three components A, B and C. There happens one more thing. Since A is miscible with B and C, so on adding A The miscibility of B and C, which were partially miscible liquids, also increases. That is, when A is dissolved, it leads to increase in the miscibility of B and C into each other. That means in the beginning, the conjugate solution of B and C was such a way that 90% B and 10% C, or 95% of C and 5% of B. But when A is dissolved in it, the solubility or miscibility of B and C also increases in each other. That means now it may be something like that here, that is 80% of B and 20% of C, or here, that is 90% of C and 10% of B. That means on adding A, miscibility of B and C also increases. As a result, we get new compositions of conjugate ternary mixtures, which are generally given as B dash and C dash. So, dear students, by this time you must have got an idea that when two partially immiscible liquids B and C were mixed in such a way that one was taken in excess and other was taken in very small quantities, we got two conjugate solutions. And when the third liquid A, which was miscible in B as well as C separately, was added to this conjugate solution, we got two conjugate ternary solutions with different compositions. And the new compositions of ternary solutions were such that miscibility of B in C or miscibility of C in B was more in presence of A. As a result, we got new compositions B dash and C dash. If we keep on adding more and more A, it results into increase in the miscibility of B and C. As a result, we got ternary solutions with different compositions. Suppose when A was added, we got this composition of ternary mixture. If more A was added, then as a result, the miscibility of B in C and C in B would increase. As a result, we got a new composition which could be represented by this point, which lies towards the right of B or which lies towards left of C. If we keep on increasing A, as a result, the ternary solutions will have compositions something like this. So these points get closer and closer as the amount of A increases in the ternary mixture. And at certain composition, there comes a point where liquid B and C become completely miscible. For example, here is the point, and this point P is known as plate point. And if these points are joined together, as a result, we get a curve, and this curve is called as binodal curve. So here, curve B, B dash P, C dash C represents a binodal curve. And in this curve, 2 points lying on a curve are joined with the help of straight lines. The lines that join the composition of two ternary mixtures on binodal curves are known as tie lines. In this case, tie lines are somewhat lower towards B and higher towards C. In other curves, tie line may be like this. They are lower towards C and higher towards B. Or at times, tie line may be parallel to BC side of the triangle. So three types of tie lines are possible. A region would be explained later on. So this is the binodal curve. There are something more you should know about binodal curve. In the beginning, we had taken three liquids, namely A, B, and C. Out of these three, B and C were a pair of partially miscible liquids, whereas A was the liquid which was miscible with B and C separately. So binodal curve forms on that side of the triangle where two partially miscible liquids are present at the vertices. One thing. Second, any point outside this binodal curve represents a one-phase system. That means all three liquids are completely miscible among themselves. It says you take any point outside this binodal curve and find what is the percentage of A at this point, what is the percentage of B, and what is the percentage of C. Then mix A, B, and C in that composition. You will get a one phase system where all three liquids are completely miscible among them. Also, since triangular plots are drawn at fixed temperature and pressure, it means the degree of freedom outside the binodal curve is 2. Similarly, any point inside the binodal curve represents a two-phase system and their degree of freedom is 1. So this is a gist of liquid-liquid three-component systems where one pair of partially miscible liquids is present. In some books, you may find this concept as chloroform, water, acetic acid three-component system. This lecture was prepared from Advanced Physical Chemistry by D. N. Bajpayee. Thank you.